Welcome to Math with Mrs. Bibb. Today we will be solving compound inequalities. First, I want to review quickly solving inequalities. For example 1, we're going to write the inequality for each graph below. I deleted the audio that I had here in this next little space, so if the audio goes away, that's because I deleted it, because I forgot that I had given you a notes guide for this one. It's the next set of notes that you don't have a notes guide. But the answer's already there, so I'm going to get rid of that. You probably saw it already, and that's okay. So if you will write down example 1 and then draw those 3 graphs, and then we will label what those graphs are. So for the first one, you can see, you can use any letter, it doesn't matter. They used Y, so I'll use Y. Y is, that's a closed circle, the shading is to the left, so that's less than or equal to positive 4. That is the inequality for the graph below. For the second one underneath example 1, that is an open circle, so I know I'm going to use either less than or greater than because these are open circles. And then the shading is to the left, so that is less than, I'm going to use X. X is less than 1.4. And for the last one, I'm going to use Z for this one. That is a closed circle, so I know I'm going to use less than or equal to or greater than or equal to because those are closed circles. And the shading is to the right, all the numbers greater than or equal to -10. So those are the answers to example 1. For example 2, we are going to solve each inequality, and then we're going to write final answers in set builder and interval notation. And I don't think that you have written these in either one of those notations, so we are reviewing how to solve, but we are also talking about how to write final answers in set builder and interval notation. So to solve, I'm going to distribute 2y plus 4 is greater than 6 plus 2y. I am going to subtract 2y from both sides. And here's a special one. 4 is greater than 6. Is that true or false? That is false. Therefore, the answer to this is no solution. And we're not going to use set builder or interval notation on no solution. Let's solve the last one. I'm going to distribute the 2. 7 plus t is less than or equal to 2t plus 6 plus 4. I'm going to combine like terms on the right-hand side. 7 plus t is less than or equal to 2t plus 10. I'm going to subtract 2t from both sides. So 7 minus t is less than or equal to 10. I'm going to subtract 7 from both sides. Negative t is less than or equal to positive 3. I'm going to divide by -1. So t is, and here's where something special happens, when you multiply or divide by a negative number, flip the inequality. So we divided by -1, t is going to be greater than or equal to -3. Now we can write that in interval notation. Oops, let's do set builder first. And I'm going to take that over here. Set builder, interval. Set builder. Set builder looks like this. you use the set symbols. So t is my variable, t such that. So it's just a vertical line, and you read that such that, and then you just put the answer. T is greater than or equal to -3. Then you close your set. So this is what this translates to. Your answer is any answer that meets this constraint. Any answer that meets this constraint. Now, interval notation, I'm going to graph that on a number line so that we can put it into interval notation. I'm drawing a white number line and I'm going to shade it with red. I go to -3, put a solid circle, and shade to the right. Now we read our number line from -infinity to +infinity. From left to right, just like we read sentences, from left to right. Where does my number line, my red number line, start being shaded, my white number line start being shaded red? So my white number line is white here at -infinity. It starts at -3. So at -3. When you have closed circles, you use brackets. When you have open circles or infinity or -infinity, you use parentheses in interval notation. So with a bracket with -3 to +infinity, that's where it stops being shaded red, and +infinity gets a parenthesis. So that is interval notation. Set builder notation on the left, interval notation on the right. Example 3, if you'll please write down those couple sentences for each of those. You can write down the first one about books and then do it, and then write down the one about electric cars. So hopefully you'll pause and then write down write down the problem. Okay, how many pages are there in the novel? So I'm going to define my variable first. X is the number of pages in the novel. Elisa has read approximately 1/4 of a novel. So 1/4 times X is going to equal 112. How many pages are there in the novel? So X is the total pages in the novel. She's read 1/4 of those. Multiply both sides by 4. So X will equal 448 pages. So I'm going to write that properly. There are 448 pages in the novel. And if you think about that, that is correct. 1/4 of 448 is 112. So if you divide 448 by 4, you would get 112. So that is the final answer. I did delete the other example that was there, so yes, right before your eyes, mysteriously, the other example disappeared. I deleted it because I failed to copy the question, what it was asking for. So if we need to do that one, we can do that in class. So if you wrote that down, please erase it. That won't need to be in example 3. A compound inequality. Two or more inequalities that are connected by the word and, that's very important, the word and or the word or. So just like a compound sentence is, I went to the store and I bought milk. That's a compound sentence. And another compound sentence, I can either go to the store or I can go home. So that is also a compound sentence. Two complete sentences connected by a conjunction. And when you look at these, the and graphs and the or graphs are different. So please make sure to pause this and write down everything that I have here for compound inequalities. When you look at this first drawing here, This is what an and looks like. This is actually the final answer of an and here at the bottom. This is the final and. The main word to remember for an and is that it's the intersection. And is the intersection. So if you look at the green and the orange, where do the green and the orange intersect? They intersect between -4 and 3. So between is a great word to indicate that you have an and problem. Between. Now let's look at an or. Oh no, I did not do it that way. I have this written to where we do the and problems first, and that's perfectly fine. So example 4, both of these are ands. Please notice that you see the word and here. You do not see the word and on this first one. So let me write that out to where you can see the word and. -8 is less than or equal to h minus 2, and h minus 2 is less than 1. So we're going to solve both of these. We're going to add 2. -6 is less than or equal to h, and I'm going to add 2. H is less than 3. I'm going to graph both of those on a number line, and then I'm going to put their intersection on this final number line. So we're going to draw 3 number lines. I'm going to color in the first. -6 is less than or equal to h on the first number line. Now that says h is greater than or equal to -6. So greater than or equal to is shaded that way. And I'll do my h is less than 3. Here's 3, it's open, and shade to the left. And then remember, we're looking for the intersection. Where do the green and the yellow intersect? They intersect between 3 and -6. So I'm going to color in between 3 and -6. And then I'm going to write my final answer in interval notation. So I'm going to read this white number line from -infinity to positive infinity, reading it from left to right. I want you to notice that the number line is not shaded red at -infinity nor positive infinity. So in your and problems, you usually do not have -infinity or positive infinity in those problems. Now let's read that number line. Where does it start being shaded red? It starts at -6, and it's a solid circle, comma, where does it stop being shaded at? It stops at 3, and that's a parenthesis. So my final answer there for that first example underneath example 4 is -6 to 3 with a bracket to the left of -6 and a parenthesis to the right of 3. Now I'm going to solve this next one. I'm going to subtract 13 from both sides. -4a is going to be greater than or equal to, is that 16? Yes, divide by -4. I'm dividing by a negative, so I must flip that inequality symbol over. So a is less than or equal to -4, and I'm going to add 14. 24 is less than 6a, divide by 6. So 4 is less than a, or you could say a is greater than 4. Those say the same thing. And I'm going to graph them both on a white number line, and then we'll put the solution on the bottom number line. So I'll graph the top one in yellow. A is less than or equal to -4. Less than or equal to -4. And I'll do the other one in green. A is greater than 4. Open circle, greater than 4. Where would the green and the yellow intersect? Would they intersect at all? This would be the intersection here. So my number line is going to be empty. This one is no solution. That is not going to happen. So no solution for that second answer. Next we have a compound inequality that is the word or. The word or has to do with the union of the graphs. So if you notice, x is greater than or equal to 1 is graphed in green. X is less than or equal to -3 is graphed in orange. And then if you unite these two, if you put these two together, literally pick this one up, put it on top of this one, you would have this graph. So the or graphs mostly look like this graph here. The and graphs mostly look like the between the two. So this or is the union, and when you unite those two, that's what you get. In interval notation, let me show you what that looks like. I should have done the interval notation for that last example, but that's okay. The interval notation for this one, we're reading that black number line from negative infinity to positive infinity. Where does it start being blue? It starts at negative infinity. You get a parenthesis, comma, where does it stop for a second? -3, and it's a solid circle, so you put a bracket. And then there's a mathematical symbol that looks like this. It is not the letter U. It looks like a U, but it's not the letter U. That's actually the union symbol. And so you have to unite those two blue pieces because there's a break here. So we have to put the union symbol here. And then we put, it's a solid circle, so we put 1 with the bracket to positive infinity. So this answer written in interval notation is here. We're going to solve each compound inequality and graph the solution set on a number line. So I'm going to solve this first one underneath example 5 by subtracting 8. 4n is going to be less than or equal to 8. Divide by 4, n is going to be less than or equal to 2. Or subtract 7, -3n is going to be less than -18. Divide by -3, n is going to be greater than +6 with an or. Okay, let me do 3 number lines. And once you get used to this, I will not expect you to draw 3 number lines. You may just draw 1 because typically, not always, but typically an and graph will look like an and graph and an or graph will look like an or graph. They do not look like each other. So if an or looks like an and, then that's a special one. If an and looks like an or, then that's a special one. Because that last one that we did for the and, that was a no solution because it was looking like an or graph. So it does happen to where it doesn't actually work, or you could get infinitely many solutions. Okay. I'm going to graph the first one. N is less than or equal to 2. Only graph in green. So 2, shaded in, less than or equal to is to the left. Do the next one in yellow. 6, greater than, shade to the right. And then you unite those two, you put them together, and when I unite them, it looks like this. It's both of those shadings put together on one number line. And then I'm going to write that in interval notation, read my white number line from left to right, from negative infinity to positive infinity. Where does my white number line start being read? It starts at negative infinity. It stops at 2 just for a second. Then union 6 to positive infinity. So, oops, I've just made a mistake. Do you all see that? This should not be a bracket because it is not a solid circle. It should be a parenthesis. That is the correct answer. That's my final answer to the first one under example 5. Let's try the second one. I'm going to subtract 1 from both sides. 5x is less than 10. Divide by 5. X is less than 2. I'm going to subtract 10 on the second one. -3x is less than or equal to -21. Divide by -3. X is going to be greater than or equal to 7. So let's look at 3 number lines. I'll color in green on the first one. Less than 2. greater than or equal to 7. And then or is the union. So this was not a special one because I can put both of those together. It would be less than 2, greater than or equal to 7. And now let's write that in interval notation. Read this white number line from left to right, from negative infinity to positive infinity. Where does my number line start being shaded red on the left? Negative infinity. Where does it stop? It stops at 2 with the parenthesis because an open circle. Union 7 with the bracket because that's a closed circle to positive infinity. So that's my final answer for the second example on example 5. Example 6, write the compound inequality that is represented by each graph below. Hopefully we've done enough here that you can distinguish which one is an and which one is an or. This is an and graph. This is an or graph. For my and, I can do the between. -2 and 4 is what it's shaded between. Put an X in the middle. Less than, or equal to. The interval notation for this would be parenthesis -2 to positive infinity. No, wrong. Scratch that. Sorry about that. There's no infinity there. It is not shaded to the end. -2, comma, it stops being shaded at 4 with a bracket. So those are my two notations. And let me look at this one. For the or, I have x is less than or equal to 8, or x is greater than 12. And in interval notation, that is from negative infinity to positive 8 with a bracket because the 8 has a closed circle. Union, parenthesis, because the 12 has an open circle, 12 to positive infinity. That's my interval notation. And that is it for compound inequalities. I hope that you have a wonderful day.